Good morning, students. Let's continue our chapter number 7, motions and work, and we are discussing about the acceleration on page number 48. Now, the acceleration is the change in velocity upon time taken for change. You have given the use your brain power. That the unit of acceleration is meter per second square. Verify this. I have given the verification in the last lecture. So now discuss about the force and acceleration. You have given in the picture, take a glass marble and let it roll on big smooth felt table top. After some time velocity will decrease and it will stop. On a carom board too, the carom coin push up by a striker will move forward some distance and then come to a stop. If the coin is pushed after applying talcum powder to the carom board, it will keep moving for a longer time and then come to a stop. Then what can we refer from these activities? That means the velocity of the coin decreases due to the force of friction and the coin stops. If the friction between the carom board and the coin is reduced, the coin keeps moving for a longer time. Then the coin is decreased. It would have means that if no force of friction is acting on a moving. Scientist Sir Isaac Newton was the first to study force and the resulting acceleration, and he gave conclusion of the Newton's first law of motion. What is the Newton's first law of motion? If no force is acting on a body, its velocity will not change. The body will not show acceleration. If a body is in a stationary position, it will remain stationary. If it is in motion, it will continue moving with the same velocity and in the same direction. This is the Newton's first law of motion. Now, you have learned what is meant by force, and you have seen that the body is accelerated due to the force. If no force is applied, then no acceleration is there. Suppose you place the 1 kilogram standard weight on a surface with no friction and pull it with the acceleration of 1 meter per second square. The force applied is the 1 Newton. That is, the Newton is the unit of the force. Here on page number 49, you have given acceleration is a vector quantity, and is acceleration is a vector quantity, and is a force vector quantity or two. That means that we have already studied that is a vector and a scalar quantity. Scalar quantity only magnitude is there, and in vector quantity both magnitude and direction is considered. In force also the direction and the magnitude is considered. Therefore force is a vector quantity. Here try this. You have given, place a weight of 1 kilogram on a smooth wooden table. Spread some talcum powder evenly on the table. Now pull the 1 kg weight on with an acceleration of 1 meter per second square. Again pull it with an acceleration of 2 meter per second square. It means that now you have applied a force of 2 Newton. You will have to take many trials for the experiment, and we conclude that force is measured by the acceleration that is produces. Now discuss about the force, displacement and work. Look at in the diagram, you have in the figure alongside a string attached to a wooden block on a table is passed over a pulley and tied to a weight. On applying a sufficient weight, the block will seen to move. Which force is being applied here? The gravitational force. How can this force is increased? What will happen on the applying more force? When can we say that work is done by the applied force? If the block moves forward, we can say that it has been displaced. Due to the displacement, we say that the force has done some work, because we know that if there is a displacement, then we say that there is a work. Can we measure this work? We know that work done depends on the force and the displacement. If we apply more force, more work is done. That means that work is equal to force into S. S is the symbol for the displacement. That is equal to force into displacement. The SI unit of work is joule, while the unit of force is Newton and the unit of displacement is meter. Therefore, the CGS system, the unit of work is Earth, and in SI unit, the unit of work is joule. Now, students, here our chapter is finished, and we discuss in the next lecture our exercise. Till goodbye.